Yeah, so good evening everyone. We'll be starting next 1 minute. Just waiting for others to join.
We will be starting the next one. We are waiting.
Okay, so we're having a very few people here in the meeting. Don't know why others are not joining.
Meeting.
I don't know why others are not. Okay, so I'll be sharing my screen now, and I'll just recap what we've done yesterday, then start from where I want to start today. So let me see. Let me share my screen. Sorry, please. Can everyone see my screen? Hello.
Yes, we can see it.
Okay. So I will just be launching the notebook. Okay.
Hello.
Yeah, I can hear you. Just calm down.
Please, okay, please, I have a few questions before you proceed.
Okay, no problem. You can ask.
Okay. Please, you will have to uh, give me explanation as regarding that where you like where you make every column that contains a zero as male and those that has one as their value as female. When you use that len something something, so the first sex, then the second sex, I want to really know what it means. And
You mean
also
this?
when you do that plots, uh, exactly there.
Okay,
And
so
when you do that group by,
okay. So when you are getting, okay, I titled it as getting little insight from the data set. So when you are working with Python and you're trying to calculate, or you're trying to get the actual number of a particular value inside a role, you have to use len. Len is like a short form of length. So when you say, okay, now from the data set, we are assuming zero to be one, zero to be male, and one to be female. Well, in some kind of data set, hello. Okay, so in some kind of data set, they might specify that, okay, oh, inside this particular column, which is sex, we might represent male as 0 and female as 1. So depending on the question, but here I'm the one assuming that my 0 is male and my 1 is female. So now I want to calculate the total number of 0 I have in that particular column. So I will have to what? I will have to use len. Then when you are doing this, you need a data frame. So this particular place is like a data frame. So data frame of a column sex then equals 0. So I'm trying to count the total number of times 0 appear in this particular column. So the total number of time it appears is 312. Same thing for female. Then for this exploratory
So
data
why did you
analysis,
like? Sorry. Can you please go back? Why did you
okay.
use the first there? You know that second that there you highlighted. It is like you are indexing it.
Yeah, you mean why did I put this first?
That one you put first. That there, that first one.
This first
Yeah.
one is my variable name for all the data sets. Can you see?
Okay.
So now I'm accessing another column inside that data set. So that means when I'm doing something like that, I need to create a data frame. So this
Okay.
particular place represents a data frame. So data frame means inside that data frame, I'm picking out a column which is sex. Then I'm now
Okay.
counting number of times 0 appear in that kind of data set or in that particular
Okay.
column.
Okay.
Do you get?
Thank you. I think I understand that one now.
Okay, so the group by, like I said yesterday, I said the first one is trying to print is inside that particular column you have 0 and 1. So that means
Yes.
it is a numerical data, which means it can be grouped. Like it's already grouped rather safe because it's 0 and 1, so it can be grouped. So now we are grouping by that particular data and we are also counting that particular data. So this particular part, this particular one is grouping them into 0 and 1. So that means you see it here like sex appear as 0 and 1 here.
Okay.
Then sorry, as 0 and 1 here, 0 and 1 there. Then later now, after this part, so this place is doing the count aspect. So when you
Okay.
use it to count,
You
it's
are
going to
calling the
display.
column, then you are counting it.
Yeah, you are grouping the column, then you are counting it.
Okay. Okay. The first part is for grouping. So say I
Yeah,
want
then
to group, I don't want to count. I will stop at that the
yeah,
first one.
you can just stop at the first one like this.
Okay. Okay.
Do you get?
Okay. Okay.
Then since I have grouped it, I can just say I want to plot. That's why I put PLT here. So someone send me a private message and say the code is not running. When you're writing matplotlib, matplotlib here, you must add a Python plot, which is pyplot. That's Python plot as PLT. So if you do not call it like this particular if you not call this particular library, you won't be able to access you'll be able to the code won't be able to run because you are not calling py plot. So what you are doing here is after you group the data sets and you count them, now you're plotting a particular kind of graph for it. You can decide to change it from bar chart to probably pie chart to anything you want. Histogram is always represented as histogram. That's histogram. Then what other ones do you have? I think that's all we use for
What?
now in the
Okay.
I think that's what we use now in data analytics aspects.
So
So
can we use pictogram?
yes, you can use pictogram, but I think I've not used pictogram. I think pictogram should be PICT. Let me try and run it. I'm not really too sure because I've never used pictogram before in all my code because I don't really deal with visualization. Let me just rerun this code. So okay, so it's still running. I told you when your code is running to show a star behind this place. So it's still running. Okay, it's done. Then I can run this. Let me try that one I just finished. Just finish. Okay, I don't. You see, PICT is not a valid plot kind. So there's a particular way they call pictogram. Let me try this. I'm not really too sure because I've never used pictogram before. So I'll just check and get back to you on that one.
Okay, thank you.
Okay.
So if to say we want to group them into three now, let's say we have a zero one, then we have let's say we have two again, like those that didn't specify, maybe they are male or female. So we'll
Can you
repeat
hear
that
you?
step.
What did you say?
I mean, to say we have we zero one, then two. Maybe those that didn't specify, maybe they are male or female.
Okay, we're
And
having zero. We're having zero, one, and two.
two.
That
So
means
like we'll group that group by we'll specify it into three. We'll like write that column. That column we'll call that column three times.
yes, you call that column three times. Yes.
I mean, in that group by we'll write it three times. We'll write that sex three times.
No, 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 no. You will just write this particular one will just be like that. Automatically, it will group the even if it is 20 that 20 it is 1 to 20 that is there, it will automatically group it by itself. You don't need to be
Okay.
writing one, two, three, four. No, 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 no.
Okay.
So now I'll be moving to so I gave us a little work to do yesterday. I said we should do pip installed scikit-learn. So I'll be explaining what scikit-learn does. Scikit-learn is a library in Python that allow you to access supervised. Let me just put as a comment here. It allows you to allows you to access supervised and unsupervised machine learning algorithms. So, like I said the other time, we won't really be touching unsupervised algorithm because of the time frame we have. But we'll be talking more on supervised machine learning algorithm. And I said when you call something supervised, that means they've already categorized it for you. Like it's already a structured data in one word. So what you have to do is to perform some prediction based on supervised machine learning algorithm and get an accuracy for us. And I said something before you can say okay you want to do before you can say you want to do prediction. Before you can say you want to do prediction, you must have a target variable, and your target variable is what you are determining in that particular data. Like for this particular data now, they've named my target variable for me as target because I told you this data set deals with heart diseases. So that means zero will represent non-disease, then one will represent disease. That's how it is being done. Even if you are giving a diabetic data set, zero will represent non-diabetic, one will represent diabetic. So that's how it is being done. So now we can also do the same thing like saying let's know how many times zero appear in this data set. Let's know how many times one appear. So we'll just do the same thing the way we do for male and female. So we can just say okay, so we can just say okay, let's create the markdown again. Let's create the markdown. Okay, so markdown. You can say checking checking the total number of times zero and one, zero which is equals to okay let's make it like this, is equals to non-heart disease, let's put it like that, then one which is equals to heart disease. Okay, so you can just run this one like that. So now if you want to calculate, so let's say non underscore heart equals okay, so non underscore heart, you can check. So you also follow the same way, learn then df, then you create a data frame again, df, don't forget it is already called target, then you close it, then you say equals 0, then you close it like this, then you close it like this, then you can run it, then you can now say okay, print, okay, sorry, print the total number of times none underscore hearts appear, then comma none underscore hearts, then you can run it. See it appear 499 times. So I can just, in order to reduce redundancy, you can just copy this, you can just say okay hearts here, then I can just change this one to 1, then I can just say this should be normal art, then this can be like this. So just like I change little things from this particular one. So if I run this now, okay, sorry, if I run this now, what was my error here? Okay, I didn't specify, so I can put 1 here. So if you see, so now when you are dealing with a target variable too, um your target variable, you must be very conscious, because if you are having a very less accuracy with your target variable, that means your data set is biased. There's something called biasness. That means we need to balance that data set. Okay, let's assume when I run this, you see the range of these two data sets is not that much. As well, this is 526, this is 499. So but like the distance between them is something like 25 to 26, or okay, let me check, 20, like 27 or so. So it's not that much. But let's say one is like 1,000, then one is like 10. There will be biasness in between that kind of data set. Then you need to balance them, but we won't be able to touch those aspects of balancing now because of the time we have. When you are balancing data set, in short, you use smooth. Smooth is just, let me you use smooth. Smooth is just like, I'm trying to, when I say when you have a data set that is 1,010, smooth will balance it for you that everything will be 50-50. Since that it will be 500-500, something like that, or just balance it that the range will not be that much. So now I've checked my target variable, the distance between them is not that much. So first of all, when you are doing machine learning data science, you need something called test and train data sets. You need something called test and train data set. So here is where work is being done. You either test with 20% or 30%. Let me make it. You either test with 20% or 30%, and either train with 70% or 80%. So when you are doing test and train, when you train with 70, you test with 30. When you train with 80, you test with 20. So that will give you, when you train your data set and you now test it, if it's giving you a very good accuracy, that means you're on the right path. But when you're having a very low accuracy, and accuracy tends to be accurate when you have 60% upward. Accuracy tends to be accurate when you have 60% upward. But most organization, they will say 60% is too small. Why don't you have 90%? Why don't you have 80% upward? But in a standard machine learning or standard data science, accuracy tends to be accurate when you're having 60% upward. So now, how will you do it? Like I said before, let me just run this now. How will you do it? I told us that we need to download scikit-learn. All the packages we want to use now is in scikit-learn. So all I need to do is I need to import scikit-learn. I need to import scikit-learn. So all the libraries I want to be using now is to be from scikit-learn. So I can just say from sklearn sklearn.model underscore selection import train underscore test underscore split. So we are training testing, so we are splitting them. So like I can just say, let me create a new place and just like mark down and say splitting data sets, into train and test. I can just run this now. So now this is my library. So I've run this library now. So what did I want to do now? I want to test with, okay, let me assume I want to test with 20% and train with 80%. So I can just say x. Oh, sorry. Before I do that, I have not splitted my data into test. I have not splitted my data into y and x train, x y test and y when x test. You need to split your data into x and y so that x will carry the attributes of my data set, then y will now carry the target variable. Like now, let me show you this data set now. For me to get this target, these are the attributes I undergo: age, sex, CP, blah 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 blah, before I get this target. So these are like the attributes. So all these things will be x value. Then only this particular target variable will be y, so that your y will stand on its own. They will know that, okay, y is the target variable. So in data science, machine learning, y is always represented as target variable. X is always represented as attribute that we use and get that y value. So now what I have to do is I have to split those data into two. So I'll just say big X equals, how do I do it? So I'll just say df dot drop. What am I dropping? Don't forget, I'll drop the target variable, since it's target variable that is only the obstruction in that particular data set. Then axis equals 1. So let me just, then I can just say y, since I said y will only carry the target variable, I can just say df then target. So if you run this now, if you say you want to view only x, if you run it, can you see there's no target again? If you say you want to view only y, okay, sorry, say you want to view only y, can you see y is only the target variable? So that's how to that. Now I've splitted my data into x and y. So now I can now proceed to, okay, let me say, okay, I can now say x underscore train, comma x underscore test. Then also same thing to y underscore what train, comma y underscore test equals train underscore test underscore split. Then I can say x, comma y, comma test size, test underscore size equals 0.2. I will explain, I'm coming. 0.2. Then what do we have? Then we can see at random underscore state equals 42. So what we are trying to do here is, okay, x, so you are going to train x, you are going to test x, you are going to train y, you are going to test y. Then don't forget, you are importing test train test splits. So obviously you have to say train test splits x and y, which is these two values that if train and test. Now testing size. So I'm testing with 0.2, that's 20%. So that means I'm already training with 80%. Random states at 42. This random states sometimes it can be one, sometimes you can put any value, but majorly it's always one or 42. Or use can't remember the last one, but use that use one or 42. That's what I know. Then if I run this particular code now and I run it like this now, you see. So I've already splitted my data into what X and Y, and it has already been split into train and test already in this particular place. So I need to use some libraries. I'm coming. Please hold on. Okay, so I need to use some libraries, supervised libraries. I'll just list them out. The ones I'm using. I'm using k nearest neighbor. I'm using k nearest neighbor. Then I'm using support vector machine, and I'm using decision tree. So these are the libraries I want to use. These are supervised library that I want to use. So when they say you use k something called k nearest neighbor is just like saying um let's say you have a rectangle now, like a rectangle, and inside that rectangle you now draw a circle. Then you now draw another one, square, and you now put a straight line in the middle. So that straight line, if that straight line has two circle and one rectangle, you consider that data to be that everything is already what circle, not rectangle. So more like on that straight line, the number with the diagram with the highest value, assume that it contains that straight line. If I'm having square there on that straight line and I'm having only one rectangle, that means square contains everything, and vice versa. So now for support vector machine, they are just supervised standard library that used to predict, same to the decision tree. So you can just read more on these libraries online if you don't really get what I'm trying to say. But these are supervised machine learning library that I want to make using this project. So now if I'm to make use of this now, how do I import all this library? So first, I told you everything you need is already in scikit-learn. So I can just say again from sklearn dot neighbors. Am I correct with my spelling like this? Yes, dot neighbors import import k nearest neighbor k neighbors classifier. Then I'm also going to do from sklearn also dot svm, that's support vector machine, import svc. Then from sklearn also, okay, sorry, this one will not run sklearn. From sklearn dot tree, since we are doing decision tree now, import decision tree classifier. So I can run it now. See, it's done running. So now these are the libraries I want to use, right? So in this particular library now, let me save it inside a variable name. I told you variable name is any name you choose and you want to use and save your data, or you choose to say, okay, I'm storing this particular value inside this variable name. So for this k nearest neighbor, I can just say knn underscore model. That's the variable name I want to choose. Then I can now say, instead of me writing this, I can just copy this particular place. Since this is what I want to use, I just copy this particular one instead of me writing it and paste it here. Sorry, I can just copy this and paste it here. Then I'll put open and close brackets. Then same thing to support vector machine. I can say svm underscore model equals svc. right? Close and open bracket. Then I can also say DTC, decision tree classifier underscore model underscore model. I can also copy the same thing here. So I've stored those particular algorithms inside a variable name. So instead of me calling K neighbor classifier or SVC or decision tree classifier, I can always be calling them by their variable name. So if I run this now, it already accepts the variable name. So now I want to fit in my train and test, and let's get an accuracy. Let's see if you use this algorithm to run this train and test whether I'll get a very good accuracy. So first of all, I can just say, okay, since it's k nearest neighbor, knn underscore model, knn underscore model, sorry, equals, okay, underscore model equals knn, okay, because knn, okay, in order not to confuse us, let me just make this small letter first, or let me just say, because this is like another variable name. I just say knn, then this one is knn underscore model dot fit. I told you want to fit in that particular data first. So what we want to fit in first, we want to fit in the train. So we are fitting in train, let's say x train, x underscore train, and you're fitting in what, y underscore what, train. So you've trained them like this. So you follow the same pattern for the rest. So enter, I can say svm equals svm underscore model dot fit into brackets x underscore train, comma, y underscore train. Then I can also do the same thing. DTC equals DTC underscore model dot fit into brackets x underscore train, comma, y underscore train. Sorry, underscore train. So I can run this now. So if I run this now, so I've already trained my x and y. And now after training them, I need to test them. Let me see that what I've trained. Let me see the value I will have when I've trained them. Let me see how it will be. Let me see the accuracy. So I can also say, okay, another variable name now. I want to store it as another variable name. I can say knn underscore predict. So this will determine your prediction. Underscore predict equals. Don't forget, what do you call them now? What do you call them now? Okay, so you can just say knn underscore model dot predict. You're predicting what? You're predicting x test. So same thing for the rest. svm underscore predict. This is a variable name equals svm underscore model dot predict. Predicting what, underscore test. Then what do you do for the next one? You have DTC underscore predict equals DTC underscore model dot predict x test. So this now, I've tested based on x tests, but I've not done for y tests, right? So I can just print this now. I can just print this now. So let me do the same thing for, let me now match y test to it so that I'll get the accuracy I want. So for y test, I can just say, so if I'm getting an accuracy, there's always an algorithm, there's always a package to in sklearn that you need to call. I think that should be from sklearn. You need to import dot metrics. Now it calculates your accuracy for you. It's metric 6 imports accuracy score. I think so. Accuracy score. Yeah, it should run. Yeah. So this is the package that will show us our accuracy score. That you show that okay, oh, this is accurate. This is the value for your accuracy. This is whatever, whatever. So I can just say print. Okay, print k nearest neighbor. Okay, let me just say. Yeah, let me just say. Sorry. Let me just say KNN. I think it should work like this. Accuracy score. So now I'm trying to match. I want to match. Now what I want to do is instead of me getting 0 point blah 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 like 5 digits, I can just round it up into round it. Then I can say okay, accuracy accuracy underscore score. Now, don't forget, I've already have a value that I already imputed the x test. Now, just remain the y test. So, this one I already done this for the train. I matched them together, but for the test, I didn't match them together because it won't work like that. Because you are predicting them based on x and y test. So now, instead of me saying, instead of me writing this thing, I can just call them by their variable name. So I can just say KNN underscore predict, right? Then comma y underscore test. So how many figure did I want to round it up to? 2 digits. Then I can close this. Sorry, I can close this. Then I can close it like this and say, okay, I think yeah, it's done like that. So instead of me rewriting this, I can just copy it so that I'll just be changing some values there. So Control C. So the next one is SVM. Then
Hello.
here is yes, I can hear you.
I've dropped the attendance
Are you
list.
saying something? Okay, okay. Thank you very
Yes,
much.
I've dropped your
Okay, so
attendance link.
okay. So the next one is SVM underscore predicts. SVM underscore predicts. Then Y test, yes. Then I can do the last one too. That's what DTC, that's decision tree. DTC, decision tree. Then here will just be DTC, yes, and that's so can you see DTC predict? Okay, so if I run this now, I should have scores. So can you see? So I told you accuracy tends to be more accurate when you're having 60% upward. So basically, this my three value are very accurate. So if I'm using k nearest neighbor to predict, I'm having 73% accuracy. If I'm using support vector machine, I'm having 68 accuracy. If I'm using decision tree, I'm having 99% accuracy. So when you're doing something like this now, I'm comparing these three algorithms now. If I'm to choose the best algorithm to work on this particular data set, it's going to be decision tree because I'm having a very good accuracy on decision tree because it's giving me 0.99. So from there, they can ask you to draw confusion matrix, they can ask you to do classification reports and how to get your is it performance evaluation now. So from what I've done now, any question? I'll just take question before and see if I can continue. Just take question. So please, did anybody have question? Please, you can ask your question.
I know.
Okay, you can ask your
Can you
question.
hear me?
Yes, I can.
What I want to say is that maybe because I don't, it seems like most of us don't, we are not tagging along with you. Maybe when you want to send, before sending the notebook,
Mm-hmm.
we should please add as much as comments and ins and markdown you can, so that while reading it, will understand better.
Okay.
Because it is something that is new, that it is new to all, at least almost everybody. So at least if we go through it, reading the comment, reading the markdown, if we have any question, then we can then ask.
Okay, I get your point. I get your point. I get your point. So I'll just see if I can add some markdown to it before I send it out. So any other question? Any other question?
Hello.
Yes, I can hear you.
Yeah, well done, Mr. Yusuf.
Yeah, thank you very much.
I've been following the codes back to back. Mine is not actually a question; it's just a commendation. So I'm following. I'm following.
Okay.
Yeah, thank you very much.
Yeah, no problem. I can hear. So any other person? Any other person? I'm waiting. Okay, if there is no other question, I'll just do confusion matrix and see if I can do the classification reports now or performance reports. Can you hear me?
Yes,
Hello.
we can.
So there's no other question. So I assume everybody is clear with what I've been doing since. So I assume everyone is clear with what I'm doing since there's no problem on the way. So I can continue, Abby.
Yes, let's continue, please.
Okay, let me just okay, so I'll be ahead. So from here now, I want to do classification reports and confusion matrix. Confusion matrix will be like, from the word matrix, it will show you the matrix format of your algorithm. So I can just say also this particular library is from sklearn. So from sklearn sklearn.metrics. Yeah, is this the spelling? Metrics. Yep, that should be the spelling. Then imports
Can you
confusion
zoom in?
metrics. What do you say?
Can you zoom in? Thank-
Is it okay like this?
Yes, thank you.
Is it okay like this, right?
Yes.
Okay. Confusion metrics. Confusion underscore matrix. So let me run this. Okay, yeah. So I've imported the library confusion metrics now. So let me just put a comment too. So that's I can put it as a markdown. So now when I'm doing confusion metrics, I can just say print since I've worked on print confusion metrics, confusion metrics underscore metrics knn underscore predict comma white underscore I can just repeat this thing for the three. So the next one will just be SVM. I think it should be in small letter. Is it in small letter or capital? Yeah, it's in small letter. SVM. Then the next one can just be DTC. Okay, so I can run this. So you can see. Okay, let me just so that it will not look clumsy. Let me just say print. It's not look clumsy. So if I run this now, can you see? So for k nearest neighbor, I have this matrix. For confusion matrix, for support vector, I have this matrix. Then for decision tree, I have this matrix. So now, even if I want to do another library that says okay, classification reports. Okay, let me make it as a comment. So let's still remember how to make use of this. But let's try. So let's just try an error in something. Confusion classification reports. Classification reports. Okay, let me run it. Okay, so let me just see first. Let me see first if it will work like this. Classification underscore reports. Oh, I've not imported the library. Reports. I've not imported the library, so let me create a new notebook so that I can import the library. So from sklearn also sklearn dot metrics import classification underscore reports. So let me try and run this. Okay, so classification reports, we show you the precision, the recall, the F1 score, and the support. So if you check what do they call it? If you check 0 and 1, 0, don't forget we said 0 represents something, 0 represent non-art, 1 represent art. So based on the precision, based on the recall, based on the F1 score, that is how we have our accuracy to be 0.73 for k nearest neighbor. You see, both of them, these are my target variables, 0 and 1. So if they say what is the precision of your non-art, 0.3, 0.73, for art, 0.74. So something like that can be asked depending on the kind of insight they ask you to get from the particular prediction you're working on. So I can do for the rest and say, okay, let me just, so that I'm not just be writing there, I can just copy this and paste it here. I can just say, okay, SVM, same thing to this. These are the factors that contribute to my accuracy. So same thing to the next one, which is DTC. Yeah, just run it. So more like these are what they ask you to do. These are like the fundamentals of data science, machine learning. So when you're saying machine learning, now if you give this data to a particular person to work on this particular data set, it will take a lot of time for the person to arrive at this result. Yes, the person might later achieve what the organization or the particular person that gave the data set, the person might achieve it, but it will take a lot of time. Look at, I did not even stress if I get accuracy of my data set. So now if they say what is the accuracy what is the decision tree accuracy for this particular data set, or which of the algorithm that you use is best okay for predicting heart diseases, you can say decision tree. So now for this particular part, they can say okay, what is the accuracy for your k nearest neighbor in order of, in ascending order, what are the accuracies that you have for decision tree, for k nearest neighbor, for support vector machine. So there are other algorithms you can use. There's Navy Bayes, there's assembled algorithms. We won't touch those ones, but I might just explain here too. Assembled algorithm are like when you merge two supervised algorithms together. Like imagine, for example, imagine k-nearest neighbor and support vector machine together. That is called assembled. Assembled algorithm, they always have their own name and they have a base classifier. So something like badging. Badging is an assembled algorithm. Badging contains two supervised algorithms. It might be decision tree and k-nearest neighbor, depending on your base classifier that you are working with. So when you see that you are trying to work on a particular data, you balance the data set and it's still giving you a very lesser accuracy. The best suitable way to use is assembled algorithm. Won't be able to touch it in this workshop. If there's avenue for us to have another workshop, maybe later, we'll talk more on assembled algorithms like that. But in this workshop, we are only emphasizing on supervised machine learning alone. So I make use of supervised machine learning and I'm done with everything I want to achieve in this data set. So if I'm asked that, okay, which of the algorithms did you use that used to predict that data set? I can say I use k-nearest neighbor, super vector machine, and decision tree. And the next question we ask is, what is your accuracy for each of them? And you can tell them. Then they can now say which of this accuracy of your algorithm is suitable for predicting this data set. You say decision tree. So, any other question based on what I just finished now? Sorry, any question? Any question? Somebody wants to talk. I'm listening.
Hello, well done, sir.
Yeah, thank you very much.
Yes. My question is just that, assuming we have a fresh set of data based on this to detect the whether heart disease or not heart disease, are
Okay.
we going to have we got like like method in programming? When you have a method like a function, you just throw your argument to it and it will supply result. This we
Mm-hmm.
have done. Are we going to repeat the entire process on that new data, or we have established something that we can just easily use to predict some fresh data set? Like when we have the x variable, we are trying to find whether those people would be able to have
No,
the target.
no, no. You mean the X and Y, right?
Yes, like we have a new set of data now that only has the x variables. We don't
Mm-hmm.
have we don't, they are still like we don't know whether they will have the heart disease or not. So we now want to use this particular train or this algorithm now to predict for them. How are we going to go about it?
Well, let me just explain. It's not possible because it is a single data set that we split into two. Don't forget, it is a single data set that we split into two. This X value are the attributes that gave us this result of Y. Do you get? Like
Yes,
this age, this sex, this CP, this traps BPS, they are attributes that will determine whether someone can have heart disease or whether the person cannot have heart diseases. Do you get? So, and don't forget in machine learning, there must be something called target variable. So my target variable is okay, after considering all these my attributes, what are my end products? So my end product of all these data sets is this Y. Do you get?
yes, I understand.
So it's just like we are trying to test and train both of them to see how the accuracy will go based on the data set that is being provided for us.
Yes, I understand you vividly, sir. My question
Okay.
is this. We have been
Okay.
able to test now and train the data set. Now, can we still use particular trained data set to predict, to make a prediction on a similar attribute in order to get whether those people are going to be having the heart disease or not? I
I
don't know whether
really
I'm
don't get.
explaining
I really please just come again. I really don't get the question.
okay, like now, maybe we now go again to collect all those attributes from a new set of people. Like this is like a sample, the trained data set, the data set produced.
Okay,
So
you're
now,
saying okay.
like I'm saying that okay, we now have a fresh data set
Okay.
with the same attributes, but we don't
Okay.
know whether they are going to get. So we now want to use the model now to
Okay.
predict that fresh data set and
Okay.
try to yes,
Okay.
try to use it to make our final conclusion, like
Okay.
in a real life situation.
Yes, I get
Is
your
it
point.
yes?
So is it possible, right?
Sir?
What's not what's the
So
complete
my
your
question
question?
is that, yes, my question is that based on what we have done now, is it
Yes.
possible that we can just translate what we have done to work on that, or we start our work afresh?
You can use this. You can use this to work on that. Yes, you can use this to work on that.
Okay, so how can we possibly pass the fresh data set to this model or this we have done in order
A
to get
fresh
that?
data set. First of all, you go back to your home. You go back to your home. Then you upload the data set. Then when you upload the data set, you can just change it here. The name of the data set, you can just change it here. Can you see this place?
Please, can you help me zoom? I'm trying to check it.
Can
Okay,
you
I'm
see
with
this
you.
place?
Yes, I can see it.
So you just change the name of this data to the new data set you have. Then when you have it, you just run all this code. It will run.
Okay. I understand.
Yeah. So once you can change the name of this data set to the actual data set you have, if you run the code, it will automatically assume that you're working on that data set you save with the name. Do you get?
Okay, thank you. Okay, thank you very much. So that means that makes it easier for us. We can be able to reuse the code for the same kind of procedure. Thank you.
Well, this is the thing. This is the thing. If you're working on another data set that is different from this one, you need to understand that data set first before you can say, okay, you are making use of this type of code. Like I was still by maybe today, I'll just borrow like another 15 minutes. I'll just borrow another 15 minutes and upload another data set. Then you see that when you have a different data set entirely, this application might not just, though you will still use it, but you need to undergo some steppings before you can achieve what you want to do, or before you can make use of this type of code for the data. Do you get?
Okay,
So let
thank you
me,
very much. Assuming it's the same data set, with the same kind of attribute exactly, we can
yes,
easily
you can
run.
use it. You can use
Okay,
it. Yes.
thank you very much. You have answered my question very well.
Yeah. So any other question, please? Okay, so in the absence of no question, I'll just probably upload another data set that I'll work on tomorrow. I'll upload it, I'll just view it, then from there we'll continue tomorrow. Just borrow me at least 10 minutes for that. Let me stop sharing now so I can access my whole screen. Okay, so let's say I go back to home, I create a new folder, I be a new notebook rather, and I choose to save it as okay, select, okay, I choose to save it as data science 2 part 2. Now, don't forget I told you there are some standard libraries you need to undergo before we can make some data analytics works, like import pandas as PD, import import numpy as np, import matplotlib dot py plot as plt, import cbon as sns. So I just run this. Now let me go and upload the data set I want to use once this particular stuff is done running. Okay, it's done. So I can go back to home. Then I'll now upload the data set I want to make use of. Okay, I think the data set should be in download also. Sorry, let me upload it again. Should be in downloads. Okay, this is it. Then I click on it. Then I open. Okay, so more like the data set has already is already existing in this my notebook. So I can just, if I overwrite it, it's the same. So let me just click on overwrite. So Now I can just come here. I can just go back to my file, my Explorer, then check that data. This is the data. Okay, let me just go. Sorry, let me just go here. Where is that download? Yeah, so I can just come here. Yeah, this is data. Then I can right click on it. Then properties. So you can see this is an XLX file, and like I said yesterday, your data set is either in CSV or XLX file. I can just copy this one. Then I can just go back to my code. Then this then I can just say my variable name df equals pd dot read underscore excel dot. So I can just run this. So can you see df? Then df, I can just, if I say df will view the data set. So more like, can you see this particular data set now? Majorly, it contains what? Categorical data like alphabet. You can see alphabet. So you don't know what this data set is all about. You don't know what we are doing. We just have to like understand that data set first. So if I want to say, okay, I can just say df dot head. I can say I want to check the first five. Can you see? I told you Python start from zero. It's recognized zero as one, so it will be 0 to 4. Then you can just say df dot tail. Then I can say first five also, the last five rather. Can you see these are the last five? So what are we doing now? We are trying to, so let's do some okay, let me stop here for now. So I'll send this I'll continue with this data set tomorrow. I will not release it as per this is what we'll work on tomorrow. Then we'll understand the full concept of when you have a data set. Now the data set I work with, which is this one. This one is just numerical data set. There's no alphabet in between, everything is numerical. Now I want to show you when we have numerical data set and we say our system only understand numerical value, which is 0 or 1 or whatever. The system does not understand this, never always. System does not understand it. So how do we transform this particular thing to numerical so that system can understand? So tomorrow we'll just click on from here. So any other question before I stop?
Hello.
Yes, I can hear you.
Thank you very much. Thank you.
Yes.
My question is all those algorithm, all those analytical listen we did, all those algorithm we use.
Okay.
Okay, let's say if they are not accurate, what does that mean? Like they are, if it is not up to the accuracy value, what does it actually mean?
I said when you're having an accuracy that is 60% above, is very accurate. When you're having less value, you have to like smooth that data set. Smooth means you have to balance your target variable. You have to balance it to 50-50. Now the range, let me go back to the range of my target variable. I'm coming. Okay, I think I checked it here. Yeah, the range of my target variable is just 27, and 27 is not that much. But let's say this one is showing 1,000. This particular 499 is showing 1,000, and this 526 showing 10. That's a lot of gap. So definitely, my accuracy will be very low. But let's say I can now smooth it. When you're making use of smooth, let me just smooth. But you can just check online and check smooth in data set. When you're using smooth balance your data set, because when you're having that kind of data, it is called biasness. But now when you smooth it, it reduces it. Though it might not be up to 50, like 500, but you balance it to the extent that it will be very closer to each other. Do you get? So that's what you do when you're having and having a lesser accuracy, that's what you would do.
Okay, thank you.
Yeah. Any other question? Any other question? Okay, so in the absence of no question, I will make some little comments on this particular data set that I just finished. Then I'll only send the Excel file of the new data set I'm working with. So you can just be checking it in your Excel sheet and see some things there. Like you see the way the data set is. Though we'll work on it tomorrow, you don't have to stress yourself. Just check it in Excel. Just open it in Excel and check how the data set is. That's all. So in the absence of no question, we'll continue from where I stopped tomorrow. Thank you very much for joining. We really appreciate it.